Hello everybody. Today we're going to be looking at another Criterion B question. This was taken from the May 2024 Extended Maths MYP paper. This was a request from one of my viewers who hopes that I could go through this question. So in my previous video, I did a very comprehensive overview of the May 2024 paper for the standard level maths for the MYP paper. So please do check out that video if you're interested. But today we're going to be looking more and to explore a little more in depth about how the E-assessment criterion B questions generally look like. Now, I had a look at this question and I felt that this question was generally very similar to the standard level mathematics paper. So if you have a look at my previous video and look at the last question, I think generally they look very similar, but I kind of feel that this could actually be even easier for the extended maths, which is a bit surprising. So anyway, let's get down to this problem, and of course please do subscribe to my channel if you have not done so. Okay, now so let's look at question 1. It says that show that the gradient of the diagonal line in stage 4 is -5/4. But before we do that, I'm going to show you a few stages. Stage 1, you realize that there is a triangle that's being formed here. So I got a triangle here. That's stage 1. Then in stage 2, you have a triangle and you realize that the only difference is that it has been moved one to the right and the original point has been moved one up to along the y-axis. And in stage 3, it goes up by another unit to the right and goes up 1 unit on the y-axis. And finally stage 4, pretty much the same as well. So the first part of the question is we need to show that the gradient of this is -5/4. So we know that this point is 0, 5 and this point is 4, 0. Okay, so back to the question. If I have 0, 5 and 4, 0 and you want to find the gradient, that's where you could use the formula if you want to, which is y2 minus y1 over x2 minus x1. So this will be x1, this will be y1, this will be x2, this will be y2. So I'm just going to substitute the numbers into the formula. So you're going to get something like that, which is 0 minus 5 over 4 minus 0. So that should give me -5/4, which is generally what the question wants. Okay, so that's the first question. Let's look at the next question, which is write down the missing values in the table up to row 6. Okay, so generally if you look at this table and if you want to go ahead and fill out this table without looking at the diagrams, I think that's generally fine, because you probably would see a very obvious pattern is that the base is obviously going up by 1 each time and the height is obviously going out by 1 each time, which is generally what has been shown in the stages with the visuals given to you in this assessment. And we realized that we got the gradient for the first 4 stages, and you realize that for the for the numerator, assuming that the numerator starts with -2 and it goes to -3, -4, -5, which means you subtract 1 each time, which means that for the next pattern this should generally be -6, and the denominator is always increasing by 1, so this will be 5 and this will be -7/6. Okay, so generally very obvious patterns for this particular question. And it says describe in words 2 patterns in the table for gradient G. Okay, so I think we can typically talk about the numerator and the denominator for that. Okay, so or another way is I would probably think that we should be looking at the numerator and the denominator. That should make somewhat some nice little patterns here. So you could say the numerator decreases by 1 right when the stage number increases by 1. So that's the first pattern. Then you could obviously say that the denominator is always increasing by 1 as well. Increases by 1 each time. Okay, so that's the pattern that I will probably write for the gradient. So it says write down the general rule for G in terms of n. So let's get going with this. So basically we need to look at the looking at formulating the general rule for the numerator and the denominator. So I'm just going to write it here. So for the numerator, since the pattern is basically -2, -3, -4, and so on, we know that if we want to, this is obviously an arithmetic sequence because the common difference is basically -1. So we do know that if you use the formula for arithmetic sequence, okay, which is basically u1 plus n minus 1 multiplied by the common difference. Now u1 is basically the first term, so I'll put -2 plus n minus 1, and the common difference would be -1. And if I simplify this, I'm going to get -2 minus n, right, plus 1. So that should give me -1 minus n. Okay, so that would be the formula for the numerator. And of course for the denominator, you probably would have realized that this is always the same number as the stage number. This is the same as the stage number, so I'll put this as the numerator, and for the denominator the formula is just going to be n. Okay, so I'm just going to write down the formula, which is -1 minus n over n. Okay, so that would be the general rule for the gradient in terms of n. It says verify your general rule for G. Again, because when this question was given, it gives you all the way from stages 1 to 4. So when you verify, you can start from stage number 5 because nothing was given to you in stage 5. So it is okay for you to verify starting from stage 5. Okay, and we do know that stage 5, the gradient was -6/5 because the numerator subtracts 1 and the denominator increases by 1. So we're just going to check by using the general rule first. So I'm going to say when n is 5, my gradient is actually -1 minus 5 over 5. That's -6/5. Okay, and knowing that this number is the same as this, since this matches the value in the table, my rule is verified. Okay, always nice to have a concluding statement to this, and make sure you have two comparisons to this. Alright, so I'm going to compare this to this value here. Okay, so that should be 3 marks in the bag. So again, we're going to be looking at the diagonal lengths for the next part of the investigation. So let's look at the first part, which is basically predicting more values and recording in the table. So I'm going to fill out the table in stage 5 and 6. So this still will be 5, 6. This will be 6 and 7. Because the base and the height increases by 1 each time when the stage number goes up by 1. Now again, if you look at the diagonal of length, typically these numbers were obtained because if you have, let's say, a triangle here. Now this is the base. Let's say if this is 1, so this is the base, and of course this is the height. So the height is 2. Now how did they get root 5 in this case? Is because of the Pythagoras theorem. So I can do 2 squared plus 1 squared, and I square root it. That gives me square root of 5. So it's basically using the Pythagoras. I could do the same thing as well to find out the diagonal length for stage 5 and 6. So this would just be 5 squared plus 6 squared, which gives me 36 plus 25. So that gives me root 61. And of course the last one, I could do the same thing, which is just going to be 6 squared plus 7 squared, So that should give me 36 plus 49, that should be 85. Okay, so typically this will be the diagonal length for this, but of course there are many ways to go about doing this even without the Pythagoras theorem, because you probably could see a pattern here as well. When 5 is added to 8 to gives me 13, this gives me plus 12, this gives me plus 16, so naturally the next one is just going to be plus 20, and of course you could do this plus 24. Okay, this is another way for you to get those lengths of the diagonal. Okay, so we're going to write a pattern in the table for the diagonal length. Okay, so I think one way to look at this is that if we have 5, 13, 25, 41, 61, and 85. Okay, so we're just going to leave the square roots out for now first. So this is plus 12, this is plus 16, this is plus 20, and this is plus 24. And what you realize is that the second difference is always going to be 4. Okay, so it says describe a word in the pattern. I think we could say that the second difference is always 4. Okay, and it says write down a general rule for L in terms of n. So typically what we need to do is to make sure that we can find a formula for these numbers in terms of n, which is basically the stage number. But typically what it means is that 5 will be considered as the first number, which is basically like the first stage. 13 will be like the second number, which will be considered as the second stage in this case. So yeah, so and we know that this is going to be a quadratic sequence because the second difference is always going to be the same, so it's going to lead to a formula that brings in n squared. But before we do n squared, we always have to find out what is the coefficient of n squared. And what we could do with this is to take the second difference and divide by 2. So I'm going to take 4 divided by 2, that gives me 2. So we know that the general rule will start with something with 2n squared. Now, what I really want you to do with 2n squared is to generate the numbers that comes from 2n squared. So the first term that comes from 2n squared is going to be 2 multiplied by 1 squared. Now the second number is going to be 2 times 2 squared. The third number is 2 times 3 squared. The fourth number is 2 times 4 squared. Okay, and if you work these numbers out, it's going to be 2, 8, 18, and 32, and so on. Okay, now if you look at 2, 8, 18, and 32, now what I'm going to do is I'm going to put these numbers side by side with the original numbers. Okay, and we're going to see if we can unlock the puzzle here. Okay, so this will be 2, 8, 18, 32, and so on. Now, having said that, now we know that in order for 2 to become 5, we need to add this by 3. Now to get to 8 to 13, that gives me 5. To get to 18 plus 25, that gives me 7. And from 32 plus 41, it needs to give me 9. So I'm trying to get these numbers to look like the original set of numbers here. Now, and we realize that 3, 5, 7, 9 is basically an arithmetic sequence. And since we know that 3, 5, 7, 9 is an arithmetic sequence, which means we can actually find the formula for 3, 5, 7, 9. All right. Since we know that the common difference is 2, so we can start off the formula by doing 2n, and of course since the first number is 3, then this will be 2n plus 1. Okay, now I have 2n plus 1 here, and I have 2n squared, which I started off with my general rule, and all I really need to do is just to combine everything together. Okay, and so when I put everything together, then the general rule in this case, all right, would look something like this. Would be 2n squared plus 2n plus 1. So this would be the general rule for these set of numbers here, which is 5, 13, 25, 41, 61, and 85. But not forgetting that the diagonal lengths all came with a square root sign. So which means if we want to write the general rule of L in terms of n, then I have to do something like this, which is going to be square root 2n squared plus 2n plus 1. And there we go. We just got the general rule for the diagonal length. Okay, so now what we're going to do is we're going to test and verify whether this rule actually is a correct rule that we formulated in the first place. So let me show you how we can test and verify this using the general rule that we just came up with. Okay, all right. Now, so when it comes to testing of the general rule, I'll put test and I'll put verify here, and I'll show you the differences between these two. When it comes to testing, you want to make use of these numbers here because these are all given to you from stages 1 to 4, and you could pick any of them. Okay, so I'm going to choose say when n is 3. Okay, let's see if this formula works. L would be equal to 2 multiplied by 3 squared plus 2 times 3 plus 1. So that should give me 18 plus 6 plus 1, which gives me square root 25. So this obviously works very well. And of course you can show with other examples with 1, when n is 1, when n is 2, when n is 4. But typically one example is good enough. Now, if you want to verify this, okay, you do not want to choose any of this. What you want to do is to choose either n to be 5 or n to be 6 or anything more than that. Okay, so I'm going to try when n equal to 5. Your L is going to be 2 times 5 squared plus 2 times 5 plus 1. And we just need to you can try to put this onto the calculator, that would be fine, but I'm going to do it without 1. So it's basically 50 plus 10 plus 1, which gives me square root of 61. And of course this value matches with this number here in the table, which you obviously could explain that this number was gotten because of the Pythagoras theorem. So if you could show both ways, alright, so make sure you show 2 ways to verify. Okay, one is by using the general rule, and the other one you could use either the Pythagoras or just simply following the pattern. Okay, so that's what will give you the maximum score when it comes to verifying your general rule. Okay, now what I want to do now for the final part is to show you how we can justify it, but I'm just going to create a new page first. Okay, oops, sorry, I think I chose the wrong one. Blank page, insert, and okay, I'm done. Alright, so what we're going to do is I'm going to show you how we can actually justify this general rule here, which is L to be 2n squared plus 2n plus 1. Okay, now please do bear in mind that when we try to show the diagonal length, remember we talked about the Pythagoras theorem right at the start. Now, what it really matters is that we need to find out what is the formula for the base and what is the formula for the height first. Okay, so we're going to write the base in terms of n. Now, we know that the base has the same numbers as the stage number. Okay, so which means that we can say that the base is basically equal to n, while the height is always going to be 1 more than the stage number. Okay, so I can say that h is equal to n plus 1. So to find the diagonal, what we want to do is to use the Pythagoras again, which means that we're going to take a square root of n squared plus n plus 1 squared. And if we can simplify this to look like this, then we will obviously justify the general rule. So let me just simplify this and let's see what we get. We're going to get n squared plus n squared plus 2n plus 1. Okay, which is just the expansion of n plus 1 squared. And if we simplify this, you're going to get 2n squared plus 2n plus 1. So this means that your rule is justified. Okay, alright, so I hope this video actually comes a long way in helping you to prepare for your Criterion B. Generally, these kind of questions are worth a lot of marks. It's worth 30 marks in total. So, and I think these 30 marks are very easy to get it because the questions generally look very similar. Just a final tip before you leave, whenever you prepare for Criterion B, just make sure you know a few things, okay? Make sure you know how to find the formula for an arithmetic sequence. Make sure you know how to find the formula for a quadratic sequence. I think it will also benefit you if you know how to work with geometric sequence as well. I think generally if you have the skills for these, you typically would do very well because it will give you like some ammunition on how to formulate general rules. Okay, now something that you also want to bear in mind is that even if you can't find the general rule, alright, it's always helpful to write something, even if it's a very simple pattern, things like, oh, the numbers are odd numbers or something like that. Just write something, okay? Because if you don't write any pattern, and even if you make up a general rule that might sound a little absurd, as long it is relevant to the pattern that you have written, you may get some credit out of this. Okay, so it's not the end of the world if you don't get the correct general rule in this case. Okay, but ultimately what I would suggest is that if you want to do well, make sure you know these skills here and get a lot of practice on that. Okay, now if you want me to make any videos on these kind of sequences or how we can find general rules with an arithmetic, geometric, or a quadratic sequence, please write in the comment section below, and I'm happy to make these videos. Okay, so yeah, so this is very much it for today, and I guess I'll see you very soon. Take care.